So in this video, we're going to be talking about simplifying radicals, and what that means is we're going to pull out perfect squares when we can, and we're going to make sure that we don't end up with any radicals in the denominator. So for these first two, we're just going to be pulling out perfect squares. So we're going to think about the factors of 24. And we're going to think, do we have any factors of 24 that are perfect squares? And just in case you don't know what I'm talking about with perfect squares, I'll list some. 2 squared is 4, so 4 is a perfect square. 3 squared is 9. 4 squared is 16. 5 squared is 25, so on and so forth. And so if I take the square root of 4, I get 2. Square root of 9 is 3, square root of 16 is 4, square root of 25 is 5. So those numbers are our perfect squares. So looking at these, are any of them factors of 24? And hopefully your answer is yes, because 24 is equal to 4 times 6. Well, I can write this as square root of 4 times square root of 6. And the square root of 4 is just a 2. And so this would be my simplified version of the radical, 2 square root 6. All right, so now we have 75. Go ahead and try this one. Okay, so we think about the factors of 75, and we could write 25 times 3. And 25 is a perfect square. That's equal to 5, and then I have left over this square root 3. So this would be our simplified version of square root of 75. Okay, so now we're going to multiply 2 square root 3 and 4 square root 6. So I'm going to go ahead and rearrange how I'm multiplying this using the commutative property of multiplication. So I'm going to do 2 times 4, and then I'm going to multiply my square root 3 and square root 6. So the 2 and 4 become an 8. And when I multiply two square roots, I can take the square root of their product. So I've got square root of 18 here. And now I see if I can simplify this. Meaning, do I have any perfect squares of 18, or factors of 18 that are perfect squares? And the answer is yes. We have 9 and 2 give 18. So I can pull out this 9. Square root of 9 is 3. So I've got 8 times 3 times square root 2, or 24 square root 2. All right, now I have this 1 over square root 2, and we're going to do what's called rationalizing. And we're going to try to make sure that we don't have any square roots in the denominator. We want all of the square roots, if we have any, to be in the numerator. So what we're going to do is multiply the numerator and denominator by something that will get rid of the square root in the denominator. And notice what happens when I multiply by root 2 over root 2. Now keep in mind, this is equal to 1, so I'm not changing the value of what I have right here any, because I'm taking a number and I'm multiplying it by 1. And so it's not going to change the value any. I'm writing an equivalent expression. So I multiply across the top. I get square root 2 divided by square root 2 times square root 2 is going to give me 2. Note that if you were to multiply 2 times 2, you'd get 4, and then you take the square root and you would get 2. And so this is actually the simplified version of what we had before, because it is rationalized. So this one is now rationalized. Okay, so now we're going to rationalize this one. We have 3 over square root 3. We're going to play the same game that we did before. So I'm going to multiply the numerator and denominator by square root 3. And I'm going to multiply across. So in the numerator I have 3 times square root 3. In the denominator I have square root 3 times square root 3 gives me a 3. And then I can simplify this fraction. Well, I have 3 square root 3's divided by 3. So these 3's are going to cancel, and I'm going to be left with square root 3. Alright, now we have 4 divided by square root 2 over 8. I'm going to go ahead and write this as a multiplication problem. So I have 4 times the reciprocal, which would be 8 over square root 2. And I can go ahead and multiply across. So I've got 4 times 8 gives me 32 over square root 2. And I'm going to rationalize this. So I'm going to multiply by square root 2 over square root 2. In the numerator, I get 32 times square root 2. And in the denominator, I get 2. I can simplify this by doing 32 divided by 2, which gives me 16, and then I have square root 2. Alright, last one. So I'm going to multiply these two radicals, and now I'm working with fractions on the inside. So remember, when we have a product of roots, I can take the root of the product. So I'm going to take square root of 3 over 7 times 14 over 3. I'm going to go ahead and simplify this however you want to in the middle. I'm going to go ahead and cancel out these 3's and say I've got 14 over 7, which, simplifying more, gives me square root 2. And then that's actually going to be my answer right there. I'm good to go.